All right, so the next thing we're going to do with the quadratic formula is talk about the discriminant. So the discriminant can be used to find good ways to solve or easy ways to graph. So the quadratic formula we just talked about is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, that division bar, or the fraction bar, goes all the way from the equal sign all the way to the end of your top. Okay, the discriminant is what is underneath the square root. So basically we're going to be thinking about, well, what if we take the square root, what kind of answers do we get out? So the discriminant is just b squared minus 4ac. Okay, so we can get a couple different answers out. So the easiest one, I think, is if we get a negative number out. If our discriminant is a negative number, the solutions we're looking for are two imaginary or two complex roots. Okay, so two imaginary roots, meaning they're never going to hit the graph. You do use them more in pre-calc and you talk about what exactly they mean. For us, we're just going to leave it at two imaginary roots. Okay, the next one that is a little bit easier, a little bit harder than the negative, is 0. So if you get a 0 number out, if you think about what that means, you're going to have your b value, your negative b value, plus minus the square root of 0 over your 2a. So if you're adding and subtracting the square root of 0, you're adding and subtracting 0. So you have some number and you're adding 0 and then dividing. Some number you're minusing 0 and dividing. Nothing's going to change. So if you have 0 for a discriminant, that's the only time you will have one root. So the next thing we have to decide, is it real or imaginary? So the only time you're going to have an imaginary number is with a negative. So that means it has to be real. Is it going to be rational or irrational? So rational numbers end up with no square root left. Okay. Irrational numbers, you might have reduced it, but you still have the square root of something. Square root of 2, square root of 21, something like that. Okay, so in this case, you would have the square root of 0, which is just 0. So you would have one real rational root. Okay, and then to me, the hardest one is the positive numbers. So if you have a positive number, but it is a perfect square, that is going to leave you with a plus and minus. Okay, so we're going to have two of them. It is not negative, so it has to be real. And if you know the square, it makes it a perfect square. So 4, 9, 1, 64, 169, 196, all those fun numbers. The square root will go away because you know the square root is whatever your answer is. So those will be rational. If you know the square root, it all won't be left in the problem. So it'll be rational, and then 2, so roots. Okay, and then the last one is a positive, but it is a non-perfect square. Okay, so if it's a non-perfect square, that means that, yeah, maybe we can reduce it and we can pull out a 2 or something like that. But at the end of the day, you're going to have the square root of 2 or the square root of 21 or the square root of 7 still left over. So what that means is we're going to have 2, again, positive numbers, so real. But in this case, it's irrational because you're going to have a square root left in there. And when you have a square root, your decimals are not repeating and non-terminating. Okay, so a couple things. If you end up with either a 0 or a perfect square, you can solve by factoring. So if you'd rather go back and solve by factoring, you can do so. I always tend to check if it's factorable first. If they're lower numbers. If they're higher numbers, then usually I'll do the discriminant and see. If I can't figure out the factors, I'll just use the quadratic formula. All right, so we can use, again, the discriminant. Example number 1, let's have 4x squared minus 7x equals, let's do 13. Okay, so first thing we would want to do is move over our number. Okay, so our C value, we'd have 4x squared minus 7x minus 13 equals 0. Be careful to only combine like terms if that is the case. Okay, we didn't have like terms, so I just write it in the order ax squared plus bx equals, or plus c equals 0, excuse me. So ax squared plus bx plus c equals 0. Okay, so in this case, a is 4, b is our negative 7, making sure you steal that sign in front, and c is negative 13. Okay, so plugging in, we only need the b squared minus 4ac. So b, in this case, is negative 7, minus 4 times our a of 4 times negative 13. So again, I just type it in because then you don't have to worry about your negative signs. Okay, so we'd have negative 7 squared, making sure it's in parentheses, minus 4 times negative 13, which is not what I typed in. There we go. Okay, and we get 257. Okay, so that's a positive number. Okay, so we were at the bottom 2. So we have a positive discriminant. Is it a perfect square or not? Way to tell is you can take the square root of that answer, and you can see that it's 16 point something something something. So it's a non-perfect square. You do not need to write that part, but just so you can see what's going on. So when I take the square root of it, I'm going to get 2 answers. They are going to be real because, again, we have a positive number. They are going to have the square root of something left over, even though that's not technically part of our discriminant. That's what decides what kind of roots we get. So we're going to have a square root left over, so that's going to give us irrational. And that's all, roots. So we're going to have 2 real irrational roots. Okay, so if we plugged in the formula, we could figure those out, but we don't need to do that. Okay, so that is using the discriminant. So just another quick example. I'm going to have this one already in standard form. So let's do 2x squared. Actually, let's just do x squared. X squared plus 4x plus 4. Okay, so if we do that one, our a equals 0, excuse me. A equals 1, b equals 4, and c also equals 4. So again, we're just doing b squared minus 4ac. So b is 4 minus 4 times our a value of 1 and our c value of 4. So I talked about this in class. When you're typing this in, just make sure you're using a subtraction sign. Those are your blue keys on your calculators and not the little negative under the 3. Okay, that'll mess everything up. Okay, so I'm going to type it in. So 4 squared minus 4 times 1, and we get a 0. Okay, so 0 is the oddball because you're adding or subtracting 0, so you're going to have 1. It's not negative, so it'll be real. You don't end up with a square root of 0 because nothing will be left over. So it is rational. And then we just have 1, so it's a root. Okay, so 2 parts of your answer, the kind of answer you get and the 0. So we could have easily factored this, where the first one we could not have. Okay, that's using the discriminant and what it means.